What if the sun fired a storm so powerful it could knock out power grids, shut down satellites, and send Earth back to the 1800s all in less than a day? Because right now the sun is acting strange, unusually frequent X-class flares, massive sunspot regions, and eruptions that have already caused radio blackouts across half the planet. Scientists warn, we've seen this before, in 1859. And it almost happened again just a few years ago. This is the story of why solar flares are surging, whether another Carrington-level storm is on the horizon, and what would the consequences would be if it happened today. Imagine waking up one morning with no internet, no phone, no GPS, aircraft grounded, banks offline, the global grid flickering, not from war, not from a cyber attack, but from something 150 million kilometers away, our own star. For the past few months, the sun has been launching powerful magnetic storms straight toward Earth. Flares strong enough to ionize the upper atmosphere, disrupt global radio networks, and light up auroras as far south as Spain and Florida. But this isn't random. The sun is climbing toward the peak of solar cycle 25, a maximum that's already more active than scientists predicted. Is the sun just doing what it always does, or is something more dangerous coming? Every 11 years, the sun changes. Sometimes it is calm, a smooth, glowing sphere with only a few small sunspots drifting across its surface. But then, almost without warning, the cycle turns. The sun's magnetic fields begin to twist, to tangle, to snap and reconnect with explosive force. This is the start of a solar maximum, the stormy half of the sun's natural rhythm. Solar cycle 25 began in 2019. At first, scientists expected it to be mild, a quieter cycle, nothing unusual. But as the years rolled on, something unexpected happened. Cycle 25 surged. More sunspots, more eruptions, more X-class flares than anyone predicted. Radio blackouts began rippling across continents. Aircraft over the Pacific lost communication. Auroras lit the skies far beyond the poles. But this doesn't mean the sun is changing forever. It isn't becoming unstable. It isn't entering some new unknown phase. This is simply the sun entering the loudest part of its natural cycle, the peak of solar maximum. And in these stormy years, the chance of something big, something powerful, is always higher. Solar flares are among the most powerful explosions in the solar system. But what actually causes them? Beneath the surface of the sun, enormous magnetic fields twist and fold. Sometimes they become so tangled, they snap. When that happens, energy is released instantly, in a flash brighter than millions of nuclear detonations. This sudden release of radiation is what we call a solar flare. Scientists rank flares into classes. C-class, small, common, usually harmless. M-class, medium, capable of radio blackouts. And X-class, the most extreme, powerful enough to disrupt satellites and global communications. A single X-class flare can unleash the energy of 1 billion hydrogen bombs in a matter of seconds. But here's the twist. The flare itself isn't the most dangerous part. Sometimes a flare is followed by something far more destructive. A coronal mass ejection. This is a vast storm of charged particles. Billions of tons of superheated plasma launched through space at millions of kilometers per hour. If one of these storms is aimed directly at Earth, our planet's magnetic shield will be put to the ultimate test. Earth is not unprotected. Floating around our planet is a shield, invisible, silent, and thousands of kilometers thick, a force field created by the planet itself. Deep beneath our feet, molten iron churns and spins. This motion creates a magnetic field that stretches far into space, forming the magnetosphere. Without it, solar radiation would blast our atmosphere away. Life on Earth simply wouldn't exist. But with it, the magnetosphere becomes our first line of defense against solar storms. When a coronal mass ejection reaches Earth, the magnetosphere flexes like a shield taking a hit. It bends, it compresses, absorbing most of the storm's energy. But the impact sends powerful electrical currents surging through the upper atmosphere, currents strong enough to overload power lines, distort GPS signals, blind satellites, and shut down radio communication across entire continents. And sometimes, those currents create beauty. Auroras, dancing lights normally trapped near the poles, can spill much further south when the magnetosphere is pushed to its limits. But even Earth's shield has limits, and history shows there are storms powerful enough to push it to the breaking point. On a calm morning in September 1859, two astronomers, Richard Carrington and Richard Hodgson, watched something impossible unfold on the surface of the sun. A sudden burst of light, brighter than anything they had ever seen, erupted from a cluster of enormous sunspots. For the first time in human history, a solar flare had been witnessed and recorded. But what Carrington didn't know was that the flare he saw was only the beginning. A massive coronal mass ejection, one of the most powerful ever measured, was already racing toward Earth. Less than 17 hours later, the storm hit. Auroras exploded across the skies in places no one had ever seen them before: Jamaica, Cuba, Hawaii, even parts of Central America. Telegraph systems, the height of technology at the time, burst into chaos. Wires hummed with electricity, equipment sparked, some telegraph papers caught fire, operators received electric shocks, and in some cities, telegraph lines continued operating even after they were unplugged. That's how intense the induced electrical currents were. The Earth itself, its magnetic field, had become the power source. Modern scientists estimate the Carrington event was several times stronger than anything we have seen in the satellite era. It didn't just disturb the magnetosphere, it overwhelmed it. In 1859, the world survived. There were no satellites, no power grids, no GPS, no internet. But today, our entire civilization runs on technologies that didn't exist back then. And a storm like Carrington's, hitting a world like ours, would be a disaster unlike anything humanity has ever faced. The Carrington event wasn't the sun's only warning. In fact, we've already had near misses. Storms powerful enough to cripple modern civilization that just missed Earth. In July 2012, the sun launched a coronal mass ejection as powerful as the Carrington event, a monster storm. It tore through the solar system at record-breaking speed, aimed right where Earth had been just 9 days earlier. 9 days. That was the difference between a close call and the largest technological disaster in human history. NASA later confirmed, had the storm hit, the damage would have exceeded $1 trillion in the first year alone. Satellites would have failed. Power grids would have collapsed. Recovery could have taken years. And 2012 wasn't the only warning. In 2003, the Halloween storms were so severe they knocked out satellites, disrupted GPS worldwide, and caused power problems in Sweden that shut down parts of the grid. In 2023 and 2024, several X-class flares triggered global radio blackouts, forcing aircraft to reroute and disrupting communications across the Pacific and Europe. Each of these events, each flare, each blackout, is the sun reminding us that extreme storms still happen, and they can happen without warning. The question isn't whether the sun can produce another Carrington-scale storm. It's when and whether Earth will be in the way when it does. If you feel like solar flares have been happening more often lately, you're not imagining it. The sun is more active right now, but the reason isn't mysterious and it isn't new. We are entering the peak of solar cycle 25, the stormiest part of the sun's natural 11-year rhythm. Every cycle goes through a quiet phase and a chaotic phase, and today we're firmly in the chaotic one. Cycle 25 is already more active than scientists first predicted. More sunspots, more eruptions, and more X-class flares in a short period than anyone expected. If a Carrington-level solar storm struck today, the world would not collapse instantly, but the impact would be like watching civilization come undone, step by step. The first sign arrives instantly, a blast of X-rays from the solar flare. They hit Earth's daylight side in seconds, causing an immediate radio blackout. Pilots lose communication over the Pacific and Atlantic. Ships at sea go silent. Aviation authorities scramble to reroute planes away from polar routes. Minutes later, the real danger begins. A radiation storm sweeps through space. Satellites shut down to protect themselves. GPS accuracy plummets. Astronauts aboard the ISS take shelter behind the station's most shielded modules. And then, the coronal mass ejection hits. A wave of charged plasma slams into Earth's magnetosphere, compressing it violently. Electric currents surge through the atmosphere and into the ground, inducing power into anything that can conduct it. Transformers begin to overload. Some trip offline, others overheat, and fail completely. As the storm builds, the effects begin to cascade. GPS becomes unreliable, throwing off navigation, timing networks, stock exchanges, delivery systems, and emergency services. Satellites become unstable or fall silent. Internet cables relying on accurate timing begin to desync. Then the worst happens. Entire regions lose power. Large transformers, devices that take months to build, burn out. Substations shut down. Some grids collapse entirely, creating a domino effect across continents. In hours, the world changes. Aviation halts, banks go offline, the internet fractures. Communication networks fail. Satellites remain uncertain. Auroras light the skies of cities that have never seen them before. And this isn't science fiction. It's exactly what the Carrington Event did in 1859. Only back then, the world wasn't built on electricity. A modern Carrington Event wouldn't end civilization, but it would be the largest technological disaster in human history. So, after everything we've seen, the flares, the blackouts, the warnings, one question remains. Are solar flares truly getting stronger? The honest answer is this. Solar flares aren't permanently intensifying. The sun isn't entering a new, unknown phase. It isn't becoming unstable. What we're witnessing today is the natural peak of solar cycle 25, a cycle that is turning out to be more active than scientists expected. Flares are more frequent right now. Some are stronger than usual, but it's all part of a pattern humanity has observed for hundreds of years. Every 11 years, the sun wakes up. It roars. It storms. and then it calms again. The danger isn't that the sun is changing, it's that our world has never been more dependent on the technology these storms can disrupt. And that's why even a normal solar maximum deserves our attention. Thank you so much for watching. I'm not going to ask you to subscribe or sign up for anything. All I ask is, could you hit the like button? It's free and it really helps the channel grow. Until next time, keep looking up.